Hi, I'm Gary of GB Educat, and today I'm presenting congruent triangles. Now, when we're talking about congruency, we are talking about two shapes that are identical in every way. All the angles are equal and all the corresponding sides are equal. But these shapes, they could actually be a translation of each other, so they could be moved, they could be rotated, or they could be a reflection of each other. So when we're talking about congruent triangles, here we've got two triangles where AB is the same length as PQ. We've got BC, which is the same length as QR. We've got AC, which is the same length as PR. But also, angle A is going to be the same as angle P. Angle B is going to be the same as angle Q. And angle C is going to be the same as angle R. And as you can see from this, these two can be mapped straight onto each other by using rotation. Now, there are four rules which we can take a look at, that if the triangles satisfy these rules, we can state that they are congruent. So I'm going to be looking at SSS, SAS, AAS, and RHS. Now, SSS means that you are given all three side lengths and the corresponding side lengths are equal in both shapes. When we're talking about SAS, we're talking about two corresponding sides being the same, but also the enclosed angle, the angle that's actually included in the two side lengths of both shapes, are equal. When we've got an angle side, we are looking for two angles which are equal in both shapes, but also the corresponding side is equal. But that has to be in the same position in both triangles. So for this, for instance, with this triangle, if this dash was here, we could not state that these two triangles were congruent. And we've got RHS, which is our right angle hypotenuse side. So if we've got both our triangles a right angle triangle, both our hypotenuse are both equal, and we've got another corresponding side which is equal, we can state that these two triangles are congruent. So we can actually use proof when we're talking about congruent triangles. Here we've got our triangle, which is XYZ. And we've been told that these two sides are equal, and we've been asked to confirm or prove that angle A is the same as angle P, where T is the midpoint between Z and Y. So we can actually assign a proof to this. So first of all, I'm just saying within my triangles, XZT and XYT, so I'm treating these as two separate right angle triangles. XZ and YZ are equal, and this is given within the problem. XT is common, so this line is common to them both, in which case this is the same length in both our triangles. And angle XTZ is equal to the angle of XYT. And this is because of construction, because what we've actually got here is an isosceles triangle. In which case, triangle XZT must be the same as triangle XYT because of right angles hypotenuse side. So angle A must be equal to angle B because all the angles within these triangles will be equal because they are congruent. I've used this term QED, but this is just a posh way of pretty much saying as demonstrated, as shown. A bit more of a harder problem to take a little look at, where we've got this peculiar shape here, and we are going to be proving that triangles APQ is congruent to BPQ. And we can prove this in much the same way as what we did previously. So we just stating first of all that which triangles we're working with. Now PQ is actually common to both triangles, this length just here, in which case we can say that's equal in both triangles. PR is equal to QR, and AR is equal to BR, which is given. So that means that AQ must be the same length as BP because of construction, because this length and this length is equal to this length and this length. Angle BPQ, so BPQ, this angle just here, is equal to angle AQP, this angle just here. Angles are the base of an isosceles triangle because just here we've got an isosceles triangle. We've got two equal sides, in which case if we've got two equal sides in the triangle, these two angles at the base must be equal. In which case our triangles APQ has got to be equal to triangle BPQ because of side angle side, because we've got our enclosed angle within two side lengths. And of course, just finishing that off with our statement, just saying that they've got to be equal QED as shown, as demonstrated. If you like what you see, please make sure you subscribe. Thank you very much for watching.